Hello, in this video we are going to talk about converting moles into mass and vice versa. So as reviewed before, a mole is a measure of quantity. It's like saying if you had a dozen elephants, you would have 12 elephants. If you had a dozen eggs, you would have 12 eggs. We can't compare elephants to eggs in any way besides amount because they're two very different things. So here, when we are looking at amounts of atoms or amount of molecules, we're going to do moles to do so because molecules and atoms are very different from one another. So here's just a little formula that we are going to manipulate in order to figure out moles or mass depending on what we're given in the problem that we're looking at. So N is going to stand for the number of moles. Given mass is the mass that the problem is going to give you. Sometimes it will give you the moles, so you'll just flip these. And then the gram formula mass is calculated on the reference table. So if it asks you for grams of hydrogen, you would do, okay, you've got 2 hydrogens because it's diatomic. 1 plus 1 will be a gram formula mass of 2. So we are going to stoichiometrically, it's a fun word, solve for the moles and the mass of these problems using conversion factors. So at the beginning of the year, when I made you use conversion factors for just converting grams into kilograms, this is why. So we're going to use those skills to convert moles into grams. Okay, so this is the problem's going to look like. You're going to be given a chemical reaction. Most times you're going to have to balance it, but in these practice problems, I already balanced them for you. And the question will read something like this. How many grams of hydrogen can be produced from 2 moles of hydrogen? So you're going to want to set up your conversion factor. The first thing you're going to write down is the value in the units that are given to you in the problem. So here we're given 2 moles of hydrogen. So that's what I'm going to write down. Moles can be abbreviated MOL, and I want you to write what substance you're working with, because here we're converting hydrogen to hydrogen, but soon we're going to be converting from one compound or one element to a different kind, and you want to make sure you're keeping track of your units. So now we're going to set up our 3 magic lines, 1, 2, 3, and plug our units in for the conversion factor. We want grams, so that's what are going to be on the top. And we want to get rid of these moles, so we're going to bring them down to the bottom here. And now we're going to convert. If we think back to our problem before, If we think back to our equation before, we are going to be looking at the given mass, and in this case, we're given the moles, so we're just manipulating this formula to rearrange it into a conversion factor. So in your conversion factor, whenever you have grams, that's talking about the gram formula mass. And we get this right from the reference table. So to find the gram formula mass of hydrogen, you would look, hydrogen has a mass of 1. There's 2 of them. So the gram formula mass is going to be 2.00. I actually want to include the 0 over here because we are going to sig fig this final answer. And then in your conversion factor, you're always going to put the gram formula mass over 1 mole because the moles of something are the grams, the gram formula mass of it. So if I said I had 1 mole of hydrogen, hydrogen being a diatomic, that mole is going to weigh 2 grams. If I said I had 1 mole of carbon dioxide, that mole is going to be equal to the gram formula mass of carbon dioxide, which is 44. So 1 mole of carbon dioxide has a mass of 44 grams. So that's what my conversion factor is. And then I would set equal. Moles of hydrogen cancel with moles of hydrogen. And we are left with 4.0, because of sig figs, grams of hydrogen. Okay? So again, just to recap, if I have 1 mole of hydrogen, that means I have 2 grams of it. So now if I have 2 moles of hydrogen, I have 4 grams of it. This is a very straightforward example. These tend to become a little bit more intricate. That's why we do the math and show the work. Okay, so if we look at this problem, it says how many grams of ammonia can be produced from 2 moles of ammonia. So I need you to memorize that ammonia is NH3. Okay, that'll just help you out with the future of our chemistry class here. So if I say, okay, 2 moles of ammonia, I'm always going to write what is given to me in the problem. 2 moles of ammonia. Set on my 3 magic lines. I want to get rid of a mole of ammonia, so that's going to go on the bottom. And I want to find grams of ammonia, so that's going to go on the top. Now I'm going to look for the gram formula mass of ammonia. Nitrogen has a mass of 14 plus 3 because we have 3 hydrogens. So this gram formula mass is 17.00, and that's 1 mole. So if I said I had a mole of ammonia, the mass of that would be 17 grams. Now I'm going to solve 17 times 2 with 2 sig figs. That would just be 24 grams of NH3. And that's how I would solve this problem. So this problem is just a little different. This problem reads, how many moles of nitrogen can be produced from 15 grams of nitrogen? So in this problem, we're given grams, so that's what we're going to write down as our given. In the previous problem, we were given moles and asked to convert to grams. So now we're just going to flip our conversion factor. We're going to bring grams of nitrogen down to the bottom because that's what we want to cancel out. And we're going to put moles of nitrogen up on the top. This is always going to be 1, and 1 mole of nitrogen is 28 grams of nitrogen. So if we pop that in our calculator, we would get 0.5357, but if we want to sig fig that, we would get 0.54 moles of nitrogen. Okay, you have to complete the units and put the element or compound that you're solving for in your units as well. When you're sig figging, we're not going to include 1 as part of our sig fig, so just ignore that. And sig fig based off the moles or the gram formula mass that you're given and using in this problem. Okay, so now I would like you to pause this video and try this problem on your own. How many moles of aluminum oxide are in 135 grams of aluminum oxide? So don't forget, when you're calculating the gram formula mass, you take the mass of aluminum times 2, plus the mass of oxygen times 3, and that would give you your GFM. So please pause this video and unpause it when you're done to check your work. Okay, so here is your answer to this problem. Oops, I messed that. It's supposed to be a 2, not a 7. So you get 1.32 moles, all right? Let's take a look at the next problem. This one reads, how many grams of aluminum oxide can form when 23.6 moles of aluminum oxide react with excess aluminum? So sometimes these problems will give you extra information that you really don't need. And in this case, we don't need the fact that it reacts with excess aluminum. That just means that you're giving it a lot of aluminum to make sure the reaction is going to happen. So please pause this video, try it on your own, and then unpause it to check your work. Okay, so after sig figging, 23.6 moles of aluminum oxide is equal to 2,410 grams of aluminum oxide. Okay, so now this next problem, it doesn't have a chemical equation that goes with it, but that's okay. You get the gram formula mass right off the reference table for copper, just like you did for the ones before. So what is the mass of 3.5 moles of copper? So you do 3.5 and then put that 0 in there for sig figs. Copper. We want moles on the bottom. That's always going to be 1. And then we're going to have grams of copper, and from the reference table, that is 63.54. And that is equal to, after sig figging, 222 grams of copper. Okay, for this next one, a chemist produced 11.9 grams of aluminum. How many moles of aluminum were used? So you always write down what's given, 11.9 grams of aluminum. I want to know how many moles. So grams are going to go on the bottom to cancel. Moles are going to come up on the top. 1 mole of aluminum is equal to the gram formula mass of aluminum, which is 26.98. Got that right from the reference table. And after sig figging, you would get 0.441 moles of aluminum. And then last but not least, we have one more practice problem. It says, how many moles of zinc are in 0.674 grams of zinc? So again, always write down what's given to you. Conversion factors, we want to cancel grams of zinc, and we want to be left with moles of zinc. 1 mole of zinc, again, in this conversion factor, your moles are always going to be 1. 1 mole of zinc is equal to the gram formula mass of zinc, which is 65.40 that I got right from the reference table. This would give you 0.0103. I want to do 3 sig figs, moles of zinc. That would be your final answer.